of Reason channel. Here we teach and train civil engineers on proper structural modeling, loading analysis, and design, including presentations, drawings of both reinforced concrete members or reinforced concrete structures and steel structures successfully. Here is a 16-story hotel building before us. What we are going to be considering is the setting that is required for us to be able to carry out a proper analysis and design of this structure to avoid an error. And mind you, there is an earthquake application at the base of this structure. And so we'll be looking at some important settings that we need to do, most especially in Protastructure, in order for us to avoid unnecessary error, even after applying the earthquake to this structure successfully. At the last floor of this structure, you can see over there we have a swimming pool. There's a provisions that we have made for that successfully. And so, go nowhere as we dive straight away into the presentations. Don't forget to like and subscribe to the channel of Reason. Let us get started. And let's not forget, towards the end of this presentation, I will show us some simple rules that you need to know while designing an high-rise building in Protastructure. What will actually guide you, okay, against failure. It is very, very important. So the point number one we will be considering while designing an high-rise structure or a tall building of this kind in Protastructure. You have to take time to study and understand the architectural plan from the ground floor, first floor, and up to the last floor. Alright? So for this structure, I will be taking us to AutoCAD now so that we will actually go through the architectural floor plans, because this will actually guide us on how to load this structure floor by floor. If you zoom closely, you can see some loading applications here. There are reasons for all of this loading because there are activities that is actually going on in those places where you have those loads successfully. Okay? So let's get to let's get to AutoCAD, and then we see the architectural plans of this hotel building. Here we go. In AutoCAD, we have all the floor plans as well as the elevations. Just as I said earlier, you have to carefully read through and understand, study the plans before you start the modeling. Okay? So if I should zoom closely to the ground floor right there, here is the basement, a kind of car park for some few cars. So the activities here has been incorporated in the modeling. As you can see, we have a basement here, and you also have the basement protrude some distance away from the columns right there, which is also considered in the modeling right there. Moving ahead to the first floor. In the first floor, we have some utilities here that we need to pay attention to, okay, like the playground right there. Alright, these provisions have to be strengthened very much, okay, by applying the required load to design the reinforced concrete member successfully. Alright, so we go straight away to the second floor. At the second floor, we have the gym right here. So this is the second floor, okay. So if you check in this model, in the model, you can see at the second floor right here, you can see some additional loadings that have already applied successfully. This is for the gyms, okay. So we proceed to the third floor. The third floor is a replicant of the fourth floor up to 9 floors right there, okay. So if you check very well, you notice we have a balcony from the third floor to the 9th floor. We have a balcony, and then the same thing you see here. There are balconies, a cantilever, okay, right there, okay. So from that point, let us go to the last floor right there. We have a swimming pool just like this, okay. So I've made provision as well for that. So you can see a swimming pool right there, okay. So getting to the elevations, if you zoom closely to this east view elevations, you will notice that we have some canopies here. Alright, and this is the protrude pavement which we have actually incorporated in the model. Okay, the next thing we will be considering here is the floor plan, is the site plan. So here is the site plan. This is a real life project actually that have designed successfully. Okay, so the next point right there is the columns sections, the choice for your columns sections when it comes to an high-rise structure. So this area, I will explain it very much well in the full video that will have to do with the modeling of this structure successfully. Okay, so at this point, we will be getting back to Protastructure so that I will take us through some important settings that you will do in Protastructure before you carry out your analysis successfully. I'll minimize this. So here in Protastructure, if actually you are applying an earthquake at the base of this structure, you should have to get the report of the earthquake informations, okay, which is the seismic parameters. So once the report is ready, you now have to get to open the seismic parameters dialog in order for you to feed in the report right there. But before then, in your project settings, you have to make sure that you enable that code successfully. As you can see, the code I use in the design are error code. So make sure you enable earthquake successfully, which will be explained fully. Okay, but once you enable it, then you click on it to bring up the dialog, just like this. Now, earthquake has a way of adding additional load at the base of the structure. That is why you need to get the report and feed in the parameters appropriately in order to avoid overloading the structure, which I will be taking us through because the design I did, there's an earthquake report. Okay, then coming to the analysis tab right there, we'll fully explain this load applications and analysis right here successfully. The structural irregularities is being detected by Protastructure successfully. Okay, so if there is any irregularity on any part of the structure, you have to leave it for Protastructure to detect it successfully. It has the ability to do that as well as post-analysis check and then response spectral analysis check. The program will detect for all of this, and if there's an issue, it will actually pop up and give you a warning. Alright, so if you feed in all of these appropriately, you may not necessarily have any issue with your structure successfully. That is why I said you must have the report of the seismic parameters. Okay, the report that contains the seismic parameter, which is the earthquake report of that construction site. Okay, alright, I'll be closing this dialog right away. The next point you have to consider is to apply a P data analysis to the structure. When you are designing an high-rise building, it is quite very advisable that you apply a P data analysis. Okay, so P data analysis, where do you get that options? If you come to the way to where you have load cases and combinations, you click right there. So in this dialog, you have a P data analysis right there. So now one may ask, what is P data analysis? But I will explain this fully during the course of the modeling of the full structure, loading analysis and design of the full structure. Alright, but I just want to let you know these are the things that you need to do. Alright, so I'll click on the OK options, and again, don't forget to enable the horizontal loadings, which is the wheel loading. Okay, this one, you have to enable this successfully, and then you make sure you carry out your wing analysis, okay, of the construction's site in order for you to get the accurate wind speed in meter per second, which I will show you where you feed it in subsequently. Click on the OK options, and then I will be closing this as well. Alright, so at this point, I want to take you to another point that you need to consider. Okay, so you get to this wind and story loads. You click right there, so you have all the stories right there and the wind capacity, alright, in mass, just like this. So you have to go straight away to the wind load calculator. So at this point, the basic wind speed right here is 25 meter per second. It is very, very important that you feed in the appropriate basic wind speed right there. Okay, and then the terrain and surrounding have to also be carefully studied so that you can also key it in appropriately. And then the building category is reinforced concrete. Okay, so you can see various building categories right here. After which you will have to Click on apply right there, or you can generate a report after having filled all of these provisions. And then click on the OK options. Mind you, you can overload this structure if you are not careful with the wind speed that you applied. It will also cause overloading of this structure. So all of this have to be followed properly. Click on the OK options. Alright, the next point I will be explaining to us has to do with merging the superstructure with the substructure. You have to make the superstructure with the substructure before you carry out the analysis. Because if you wouldn't do that, you will be having some challenges and errors. So how do you do that successfully before analysis? If you come to this analysis tab, click on the building analysis, and then you come straight away to where you have model options. In this model options, you notice that soil structure interactions, you only have a user defined support. Okay, option being checked. Take it to merge foundation model. This one integrate modeling of foundations and upper structure. So you have to use these options, not this one. Okay, so this is very important point I'm trying to make in this video for us. If you have any questions, you can as well drop in at the comment sections as well. Okay, and also don't forget to like and subscribe, please. All right, so we make progress. You have to use this merge foundations model, which integrated modeling of foundations and upper structure successfully. Now most of these options I'm showing and points I'm making actually applied to when you are designing a tall building, all right, in Protastructure. Okay, so I'm taking you through the proper way you can do that effectively. Alright, so you can go also to slab model right there and be able to enable a finite element for any of these floors, okay, that you wish, because you have almost all the floors right here. Okay, so you can enable that and then include the column sections at FA and all of that before you carry out the analysis. Okay, but this options is not that necessary. It's just that if you want that to be done using the finite element analysis options. The first options I've shown you, which is this one, is very important. So you have to take note of that. Okay, so we make progress. I want to be closing this right away. Okay, the next point is how to enable impact load reduction. So impact load reductions is actually enabled when you are designing an high-rise structure of this kind. Okay, so we can do that actually as we proceed to the stories right there. We right click and you see these drop down options, or you can also pass through the building center right there, come to story operations, you still see the same drop down options. They select this edit story options right there, and then you have edit story dialog just like this. In this edit story dialog, this is where you have the foundations, depth and the rest of that, but we are concerned about the load reduction. So you can see the loading reduction right there from 50 to 40, and then as you goes up, okay, the load gets reduced. Okay, so you can actually enable this impact load reduction successfully by clicking on the apply options right there. You can see impose load reductions. Okay, and don't forget to be part of our training program so that you learn more about this successfully. Okay, another point is structural system. Okay, so don't miss ROC with steel. Okay, make sure you check this properly to ensure everything is properly set successfully. So this point is also very important. Clicking on the OK options right there, just as I said earlier, be part of our training program, okay, so that you will learn more about tall structural design in Protastructure and as well as other softwares. All right, so we proceed. All right, the next thing or the next point I will be making is your choice of foundations. The choice of your foundations actually depends on where the building is being sited. Is it sited in an earthquake related country? Also actually determine your type of foundations, and then the soil bearing capacity is very important. Okay, so if the soil bearing capacity is very okay, you can go by this type of foundations. But if the soil bearing capacity is very poor, you can actually go for deep foundations, which is the pile foundations. All right, okay, so the next point and the rules that you have to have it at the tip of your finger while designing a tall structure in Protastructure is ability to actually interpret a warning and know the implication of that warning. So there's a warning I want to be showing us now. Maybe you run analysis and then you see that warning. Please, you have to check the structure, because having that warning in the structure is not safe. So here is the warning. Warning in direction 1, relative story draft exceeds the limit. Alright, and as well as direction 2. So once you have this warning in your after your analysis and design, this warning may not necessarily interrupt your analysis as not to carry out successfully. Okay, the analysis will be done, but you have this, but never play with this warning. You have to rectify this warning. Okay, this warning is simply telling you that your superstructure is heavier than the substructure, and in the design of an high-rise structure, it is always put in place that your substructure is more heavier than your superstructure. That is a simple rule you have to put in place. A Protastructure will detect that with this warning that is you are seeing here. Okay, so once you have this, simply means that the superstructure is heavier than the substructure, and that is not okay. Meaning your structure is weak at the substructure. Okay, the building is weak at the substructure, and it can collapse. Okay, so you have to rectify this. In the subsequent video or the next video I will upload on this channel, Soft Reason, we actually on how to resolve this successfully. Okay, so the simple rule is that design your structure, a tall building, in such a way that the substructure is more heavier than the superstructure. That is it. All right. So in the subsequent presentations, we will be looking at the full modeling, loading analysis, and design of this structure. So don't forget to like and subscribe. Stay tuned so that once the video is uploaded on this channel, you will be alerted. Okay, so we bring this presentation to a stop here, and then we'll see you in the next presentation. Stay safe and stay connected. Bye for now.